Hello everyone. In today's topic, we are going to discuss about angles in circles. What are central angles? A central angle is an angle whose vertex is the center of the circle. This is a central angle. This is also a central angle. And this is not a central angle. Now let's move on to central angles and arcs. The measure of a central angle is equal to the measure of the intercepted arc. So if we have this central angle which is equal to 110, then the intercepted arc is equal to 110 also. So let's move on to inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords. For the first one, it is not an inscribed angle. The second one, it is an inscribed angle. The third one, it is not an inscribed angle. Instead, it is a central angle. And for the fourth one, it is an inscribed angle. Inscribed angle theorem states that the measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So the measure of the inscribed angle is equal to 1/2 the measure of your intercepted arc. Now let us have different types of inscribed angle. So in this diagram, and this one, plus this one and this one, the angle in the red shade, it is equal to 1/2 the angle in the green shade. Okay? So I'm talking to this angle. So this angle is 1/2 this angle. Or because the central angle is equal to the intercepted arc, so this is 1/2 of your intercepted arc, okay? And since the central angle is equal to the intercepted arc, so therefore, your inscribed angle is equal to half of your central angle as well as your intercepted arc, okay? So let us have an application on inscribed angle theorem. So if this is your inscribed angle, and this is your intercepted arc, meaning your inscribed angle measures half of your intercepted arc. So if the intercepted arc is 110 degrees, then automatically your inscribed angle is 55 degrees. So let us find the value of x and y in the figure. To solve for x, as you can see here, the intercepted arc equals 40 degrees. So automatically, we are just going to divide it by 2. So 1/2 times 40 degrees is equal to 20 degrees. For y, first we are going to analyze the intercepted arc. Since the inscribed angle is 50 degrees, the intercepted arc PR is equal to 100 degrees. So times 2. And then the whole of this one is 100 degrees already. So we are going to subtract 40 from 100 degrees. So y equals 100 degrees minus 40. It is equal to 60 degrees. Now, let us find the value of x and y in the figure. So in here, we are going to have this intercepted arc which measures 100 degrees. So this is the inscribed angle times 2. It is equal to 100 degrees. And then we are going to solve for your x. So x equals 50 degrees. Why 50 degrees? Because this is the intercepted arc and this is your inscribed angle, which is your x. So 100 divided by 2 is equal to 50 degrees. And take a look at your y. Also, the intercepted arc is 100 degrees. So all we need to do is to divide it by 2. So y equals 50 degrees. An angle formed by a chord and a tangent can be considered an inscribed angle. N, and that measure angle ABC is equal to half of the measure of your arc AB. So whatever the measure of this arc, AB, just divide it by 2, you will be getting your measure angle ABC. So let us have an application of this one. So supposing we have measure angle PRQ. So measure angle PRQ equals 1 half the measure of arc PR. Now, let us solve what is measure angle PRQ. So since we have the inscribed angle 60 degrees, therefore automatically this arc is equal to 120 degrees. And from that, we are going to divide 120 degrees by 2. So therefore, measure angle PRQ equals 60 degrees. An angle inscribed in a semicircle is a right angle. So once you have the angle inscribed in a semicircle, this one, of course, 180 degrees divided by 2, it is automatically 90 degrees or a right angle. Now let's move on to interior angles. They are angles that are formed by two intersecting chords. And remember that the vertex should be in the circle. So let's move on to the interior angle theorem. It states that the measure of the angle formed by two chords is equal to 1 half the sum of the measures of the intercepted arcs. So the measure of angle SVT equals 1 half times the measure of arc SR plus the measure of arc TQ. We can also conclude that this angle, angle TVQ, is equal to 1 half the measure of arc SR plus measure arc TQ because we all know that vertical angles are congruent. So let us have this diagram. So in the diagram, we can conclude that measure angle 1 equals 1 half times the measure of arc AC plus the measure of arc BD. Now, we are going to solve for x and y. For x, as you can see here, x is equal to 91 plus 85 divided by 2, or x is equal to 1 half times the sum of 91 and 85. And 91 plus 85, it is equal to 176 divided by 2. So x equals 88. And for y, since the relationship of x and y, they are linear pair, they form a line. So therefore, we are going to subtract 88 from 180. So 180 minus 88, it is equal to 92 degrees. So y equals 92 degrees. So let's move on to exterior angles. An exterior angle is an angle formed by two secants or formed by two tangents, and under two tangents, these lines are congruent. And it is also formed by a secant and a tangent. So the measure of the angle formed is equal to half the difference of the intercepted arcs. So this time it is the difference, so we are going to subtract. To solve for measure angle 1, it is equal to 1 half times k minus j. So let us have an example. Referring to the diagram, we need to find measure angle ACB. To find measure angle ACB, all we need to do is to subtract 265 minus 95 and then divide it by 2. So 265 minus 95 equals 170, and half of 170 equals 85. So therefore, measure angle ACB equals 85 degrees. So an additional information about inscribed quadrilaterals. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. If we mean supplementary, it adds up to 180 degrees. So therefore, if we have measure angle PSR plus measure angle PQR, it is equal to 180 degrees. So that's it for now. Thank you for watching. See you again next time. Bye.